Hello, and welcome to today's live session, Automated Gas Manifold and Safe Purging, Best Practices. I'm Rachel Seiler, today's host and Marketing Communications Manager for E1. Before we get started, I have some housekeeping notes. All attendee lines have been muted. We'll be recording today's session, and an archived edition will be available on E1's website, as well as our YouTube channel. Upon successful completion of today's webinar, you'll receive a PDF of this presentation, as well as a certificate of attendance. And finally, we'd love to hear from you. We've allotted at least 15 minutes of Q&A throughout today's session, so please make use of this time. And if we don't get to all your questions, we'll answer them in a follow-up email. So now, without further delay, I'd like to introduce today's presenter, Mark Williams. Mark is E1's Regional Manager for the Americas and has more than 12 years of experience in E1 sales and over 30 years of field service customer support experience. Mark has worked closely with power plants around the world in areas of maximizing safety and risk mitigation. Mark, take it away.
Thank you. Thank you for joining me today to talk about automated purge systems, how they work, their advantages, and best purging practices. There's a lot of talk about automated purging and fast degas these days. This needs to be a safe, repeatable process the operator has control of and can monitor right from the control room. Fast is not always the answer. How fast is fast? That depends on your application, your current purge procedures, not to mention the manufacturer's recommended flow rates and limitations of your piping and gas supplies. What we'll discuss today will cover these topics and go over the information we need to understand to be sure the equipment is designed and the processes are identified to ensure safe, reliable plant operation of an automated generator purge system. We're going to do a hydrogen safety review to start off. We're going to talk about what a safe auto purge system is, what the benefits of an auto purge system are, and what we need to know and understand about the current manual system. We're going to get into understanding CO2 and CO2 delivery issues. We're going to look at some best practices for safe purging. And then lastly, we're going to look at a few options for automating your purge system. I'd like to start out following a practice that I've had participated in plants before. Most any walk down of a system, pretty much like a pre-job briefing or a safety briefing. Let's start with some hydrogen safety best practices. Hydrogen is colorless, tasteless, and odorless. It's the lightest gas with the best heat transfer rates for all gases. It's non-corrosive and considered non-reactive, excuse me, but it can cause metal embrittlement. As you can see in the center of the slide there, it burns with a clear bluish, almost invisible flame. It is the lightest gas. It is number one, and it's the most prevalent gas out there. One of the big important things that I'd like to stress is the explosive limits. I've been in many occasions when people are plus or minus 5% on these numbers, and I think it's important to take a breath and say that we need to know that the explosive limits are 4% to 76% volume in air. Again, I'd like to repeat that. Explosive limits are 4% to 76% by volume in air. We're all familiar with the fire triangle, the elements necessary for that triangle. It needs to breathe, it needs fuel to burn, and there must be an ignition source. When these three legs come together, we have a perfect storm situation. Keeping this in mind, we must think about when keeping these things in mind, we must think about when dealing with hydrogen are the generator fleet is getting older. Our hydrogen auxiliary system equipment is getting older as well and becoming obsolete. Our workforce is getting younger and leaner, and training programs are less frequent. Time between outages are getting pushed, either for pure generation of power or financial reasons. So we're going to now let's talk about a hydrogen safety triangle. The safety triangle is the right people, the right process, and the right equipment. Those three legs create a safety triangle. In addition to the inherent risk of working with hydrogen, the associated hydrogen auxiliary equipment is getting older and outdated. If you look back 13 years ago when I started in the power industry, it had the oldest average aged workforce for any industry at between 52 and 54 years old. Now, after 12 years with retirements, the years of knowledge that has gone away, the outages are getting pushed out to maximize run times, which means less degassing and regassing of the generators with a less experienced, leaner workforce. This puts us in a situation that we need to be more careful of our process, our equipment, and available manpower to avoid negative events. Even well-designed generators can become compromised by these serious operational challenges. We know if proper procedures are not followed, you can have some very serious problems, including equipment damage and loss of life. In these instances, there was an equipment failure which led to hydrogen leak into the exciter. All three conditions of the fire triangle were met, and a fire and explosion occurred. In the second was a purge procedure failure. Luckily, there was no loss of life as a result of either event. Questions at this point?
Hi, everyone. If you have a question at this point, there's a Q&A function on your screen, and feel free to type in one if you'd like. We'll just give it a minute, Mark. And
okay.
If we don't have one come through, we'll just move right along. Okay, I think you've been pretty clear, so go ahead.
So, what is an auto purge system? On the left-hand side of the screen, you can see a fully automated gas manifold with manual functions that has gauges and transmitters. And probably on the left is what most plants today have, which is a totally manual system that's been around for years. Multiple turn valves with seats that dry, don't always seal well, and can leak by. So what is an automated purge? It's a way to bypass the manual valve system with the press of a button without leaving the control room. It has a repeatable process designed to meet your generator's requirements for a controlled, safe purge, and it allows you to monitor or adjust the process when activated. It's a safer, more efficient way to purge your generator. So what do I mean not leaving the control room? An operator with a push of a button, you have a system that is controlled in your DCS utilizing 4 to 20 milliamp signals from rotary actuated valves on the H2 supply, the CO2 supply, and the vent line, with a permanently installed H2 monitor set in H2 and CO2. In the vent, you have to do an emergency purge. Having this gives you the ability to monitor valve positions to confirm they are in the correct position, the pressures for supply gases are present for the purge, the case pressure is properly maintained, and you have a purity purge reading for H2 and CO2. So let's talk benefits. So what are the benefits of an automated purge system? It's a repeatable, tested process that is set up in your DCS, having preset logic that you have control of to make changes if needed. Having the logic in your DCS eliminates human error, such as opening or closing the wrong valve, connecting the wrong gas, grabbing the wrong procedure for the generator that's going to be purged. As we discussed earlier, the workforce is getting younger and leaner, reduced knowledge and manpower. It can save time for emergency purge and planned outages by streamlining the process so you can come offline faster and get back online faster with less manpower involved. I've been told some sites require up to 3 people to purge a generator that can occur over multiple shifts to complete. I've heard up to 12 hours for just a CO2 purge. By having a set, tested process with the proper equipment will save time and manpower. It can help protect personnel and equipment in the event of a generator emergency or natural disaster, such as a hurricane, tornado, or flood. And by not sending people out to the generator to do a manual purge. Because we give you the signals and let you control the logic, it can be applied to any generator setup, and you have control of the changes if needed. Okay, now we're going to get into what we need to know. So when I go to sites and we start talking about automated purge, there's a long laundry list, I would say, of questions that I like to ask, because they're things that we don't think of every day. They're important. And once we understand them, we can get a better idea of what the capabilities are at present and what we can do if there's some slight changes or modifications in procedures or plans for your purge. So the big one is, what's the volume of your generator case? How many standard cubic feet of gas does your generator hold? 2,400, 3,200, 500? What type of purge are you using? Is it a blanket purge, where you do a slow controlled purge, blanketing the gas, pushing the hydrogen out of the top of the generator? Or is it a pressure purge, where you're dropping the pressure of your case from 60 or 30 PSI down to 10 to 12 PSI and repeating that process 3 times and forcing the gas out of the bottom header of your generator? These are important things we need to know. How is your CO2 stored on site? Are you using high pressure bottles that run somewhere between 800 and 1100 PSI, or low pressure bulk tanks at 300 to 350 PSI? Do you have enough CO2 for a complete 2 volumes of gas available for an emergency purge? Now here's a big one, and I found by going through purging documents, procedures for meetings before I arrive and start talking about them, and have somebody raise their hand and say, hey, that's not exactly how we do it. So it's like, wait a minute, that's what's in your purge procedure. Shouldn't you be following the procedure? Yeah, we follow the procedure, but that's not it. So the big question is your purge procedure up to date? When was the last time you reviewed your purge procedure? Have you reviewed the purge procedure for consistency throughout the document and accuracy? Is your P&ID up to date? Has there been any modifications or valve replacements that you have not documented or updated this with? When was the last time that you got your P&ID, your purge procedures, and went out to the gas manifold and checked to be sure that the valve numbering is correct, there were no changes have been made on the manifold that haven't been documented, and that the procedure matches what you have there as your existing manifold? Now, this is a big one that I've talked about and discovered. What pressure do you flow your generator CO2 gas at? I've seen anywhere from 63 psig to 15 psig. And why? Why are those numbers picked? There's an assumption that if you deliver gas above seal oil pressure, that it will blow the seals out or cause freezing in the regulator valves and pipes. As long as you keep that pressure up at 60 psi or above, you won't see any of those things. Your vent valve is actually controlling your case pressure to make sure it's maintained properly so that you don't blow out the seals. One of the ways I've used to describe this is, imagine you have a balloon, it's got a small hole in it, and you start trying to blow that balloon up, and you're blowing and you're blowing. That balloon is only going to inflate as much as that small hole in it will allow it to get to, no matter how hard you blow or how long. It's a controlled leak of gas. It's kind of the same way that I relate to the process. As I said, adjusting your vent line will help you maintain your case pressure. I actually went out to a plant in New Mexico probably 6 months ago to help with a purge, and we were able to control on a manual system between 2 and 3.5 psi of case pressure so that we wouldn't blow out their seal oil system. So it can be accomplished. So sorry about that, I got lost for a minute. As we just discussed, the CO2 pressure feed and gases, I'm a slide behind. Okay, CO2 purge equipment. Do you have a method of confirming CO2 gas is flowing to the generator? Or is it an assumption? Are you counting bottles used? Are you making a manual tank measurement at the start and finish of the procedure? What is your method of confirming CO2 is flowing to the generator? And is it accurate? Do you believe it's accurate? Do you have a CO2 flow meter with a visible readout that you can match flow against time to know how many standard cubic feet you've flown to that generator? Do you have a CO2 vaporizer? What's its process? If it's heated, is it electric, steam, water? Or do you just rely on the portable gas analyzer for flow and reading to confirm gas flow? If you have bulk storage, is it used from multiple generators on a block? Is your bulk storage used for any other application, like fire suppression? Adding a generator purge process to this type of system may void your fire suppression certification. So we need to think about that if we're going to an automated purge and want to use a localized tank. If you have bottle packs, do you have a method of confirming your bottle packs are full and have not been used or leaked down? Are you weighing them? Do you have them swapped out periodically? You got to think about that. We want to make sure that we have enough gas available when the time comes to push that button. We can help you review your process as part of an auto degas project. We've found in many cases that changes have made to the manifold that have not made it into the documentation. This gives us the information that is critical to understand the best way to move forward. We ask these questions because we want you to be part of the process and have a good understanding on what we must work with to accomplish your automated purge system. By doing this, we become a team. We work together, we exchange information, and get confirmation we are going down the right path to accomplish your desired results. Questions at this point?
Okay, hi Mark, it's me again. We'll just give a minute here.
Okay.
It's the pause that refreshes. So. And I don't see any questions coming in, so go right ahead.
All right, next. Now let's talk about some of the delivery issues we see with CO2. This is something that about 2 years ago I started doing research on and investigating in Mexico, driving from Monterrey up to Rio Bravo after we'd visited a plant that was always having freezing of its regulators and its bottles, even though they had a vaporizer, trying to figure out why does this happen? So I started searching the internet, and these are some of the things that I've come up with and I've learned to help me better understand how that I can help you, and we're going at the right things and going down the right path. So high bottle pressure storage, 800 to 2200 or 1200 PSIG. Large pressure drops below 60 PSI can be a big issue. High ambient temperature is also an issue. Regulated pressure and flow delivery can cause freeze up of the regulators, pipes, and bottles, and non-confirmation of gas flow, relying on time. We discussed delivery pressures as low as 15 PSI earlier. With pressures this low, your flow rate must be very low to prevent freezing of the regulators and bottles if you're using high pressure bottles, which will increase your purge time. Can be anywhere from a 12 to 16 hour process going at those low pressures and rates. If you increase your pressure to 60 PSIG or higher, you can increase flow rates and decrease your freezing issues. If you have bulk storage tanks with lower starting pressures, 300 PSIG approximately, your pressure drop is greatly reduced. Then combining it with delivery pressures above 60 PSIG, you can greatly reduce freezing opportunities. Adding a vaporizer can potentially eliminate this freezing process. Why CO2 freezes? Cooling comes from two sources: pressure drop and velocity, time of flow. When there's a pressure drop of more than 2 to 1, say from 1100 to 100 PSI, or from 100 to 30 PSI, the potential freezing up of pressure from pressure drop combined with purge time is extremely high. Freeze up refers to a pressure regulator becoming clogged with dry ice, snow, or crystals, which restrict the flow of gas through the regulator or the pressure control valve. Freezing occurs when the gas undergoes the pressure drop at the regulator valve from the inlet pressure to the delivery pressures below 60 PSI, emerging of a gas and solid CO2 mixture. I'm getting a little bit lost here. Okay, so moving to, go ahead.
Yeah, you're just on the freezing portion.
Very good.
Of CO2 freezing. Yep.
The downstream pressure of, if the downstream pressure is above 60 psig, the mixture is a gaseous and liquid CO2. Below 60, the mixture is gas and snow. This is a very important point to remember. Solid CO2 cannot form at pressures above 60 psi. It occurs when the gas undergoes the pressure drop at the regulator valve from inlet pressure to delivery pressure below 60 psi. CO2 regular piping frost. As a result of the moisture in the air freezing and accumulating on the exterior surface, is not related to the CO2 freezing effect and typically has no effect on the performance of the regulator. So what can be done? You can install a CO2 trim heater or vaporizer, pipe directly from the bottles or bulk storage tank, maintain delivery pressures at 60 psi or above, add a heated regulator to prevent frost buildup at the orifice, identify weak links in your CO2 delivery system or storage supply. Look around, update your CO2 storage tanks to bulk or mini bulk tanks from bottles. Questions at this point?
Yep, we've had a few come in actually. So this is from Anonymous. At what interval should purge system be walked down and the procedure reviewed?
I would say probably at least yearly, just as we do with calibrating any of our instruments for our online monitoring stuff. Would be a definite good start point.
Okay, thank you. And Kevin asks, to decrease outage time, should we consider replacing our purge vent pipe with larger diameter lines?
That depends, I would say, on the size of your vent pipe. The vent pipes are usually a 2-inch line. Most of the decrease in time that I've seen has been by actually increasing the delivery pressures going to the generator case and then getting a good solid portable gas analyzer that's been calibrated so that you can see that your purge process is moving forward or completed. I had one site that the site in New Mexico that I went to. They were started out somewhere around 12-hour purge time for their generator. And they were having issues with readings and they were worried. Sorry about that.
Okay. Here's another question from Kevin. Can the E1 system accommodate the introduction of tracer gases, such as helium or CO2, during the gas pressurization process or while online?
We have not gone down that path, but I guess it's possible that you could feed, put a T in somewhere and put those tracer gases in for your leak checks.
Okay, and from Stephen, here's a question, would heat tape or heat trace, on CO2 regulators help prevent freeze up?
Yes, that can. I've seen that in a couple of plants that have done that. But the thing we got to remember is that we're in an area that has hydrogen, so they need to be intrinsically safe. I've also seen heated regulators out there that will help with this freeze up and frosting issue.
Okay, and that's it for now. We'll move along and get to some other questions later. Thank you.
All righty. So let's start talking about the purge process and what good practices are. One of the most critical processes associated with hydrogen-cooled generators is the purge process. As I mentioned earlier, outages are becoming less frequent. And as a result, the plant personnel may not have had any experience purging a generator when the time comes for the generator to be purged. Having a good purge procedure and associated equipment are critical to safe plant operation. We'd like to see personal LEL, lower limit explosive detectors, non-sparking tools, verify that we have sufficient CO2 is available to purge all generators on the site, create signage in key areas to know if there's gas in the generator. That's a good one that's been discussed a few times with my colleagues, that having a sign that says I'm on hydrogen, I'm on CO2, or I'm on air, clearly visible, will also help somebody from going to the wrong generator and starting a purge where the incorrect gas is pushed in. Communication, that is the key for all of this. Is operations, INC, need to talk. We need to make sure that our procedures are up to date and we have the correct procedure for that generator when we do the purge. Portable gas analyzer, very important thing. Making sure that it's calibrated and it's up to date. If it's been a year since a purge, you need to do a calibration. I wouldn't go past 6 months without calibrating a portable. Hydrogen leak detectors, those are also important. With these old valves and valve seats that tend to stick and freeze up sometime, they do leak, and knowing this is a good thing. I know of an event where there was 3 valves on a manifold that had pressurized hydrogen to it that leaked by, and it had a small explosive event in the generator that caused downtime and a lot of serious concern. So this could be a very important item to have. Personal LEL detector. We have these when we go out to the sites, and I've had them go off walking around equipment, identifying leaks that we never would have known were there. Non-sparking tools. Bronze, nibral tools are very important. You don't want to go onto an old manifold that's made of steel with more steel tools and possibly create a spark or an arc that could set off a fire. Questions? We'll take some more at this point.
Yep, there's one. Does E1 charge for the on-site evaluation?
Actually, no. I'd be happy to come out and do that and walk down your system, help you look through your processes, identify the strong points, the weak points, and of all of your hydrogen equipment for that fact. But that's one of the things that I really like to do, is to get out in the field and hear what you need, hear your concerns, and take a look at things. We do this on just about every call we do. And that's part of our process, to be an advisor, to be trusted.
More on that collaboration later. We don't have any other questions that have come in, so go ahead, please.
Alrighty. All right, these are the options that we've looked at and are currently installed, well, across the world. On the left, we have what I call a cut-in automated gas manifold. When we use this this manifold, it's just the automation portion of the manifold. We pipe in around the valves so that we have a path to bypass the manual valves using rotary actuators on rotary actuated valves, 4 to 20 milliamp signals on your hydrogen CO2 supply and your vent line. There's also a pipe in for a permanently installed hydrogen analyzer that we can have set up in H2 and CO2 at all points in case you have an emergency. The unit in the middle is more of a complete cut the pipes and repipe everything, the 6 pipes back in, your top header, your bottom header, your CO2 line, your H2 line, your vent line, and your sample port back into the manifold with pressure regulators or pressure gauges, transmitters. It's fully manual. It also has lockable valves with a spool piece that actually you have to actually manually go out there and take it apart and move it over. This particular manifold doesn't have a built-in analyzer, but that's something that can be moved, that we can move to if needed to. On the right, excuse me, that's my dog. On the right, there's an automated manifold with the online H2 monitoring system, where we have the fully automated manifold like the other two. We kind of combine the other two to come up with a complete system. It has online redundant analyzers, one for full-time monitoring of the unit while it's running. We have a second analyzer set up to be in a CO2 and H2 emergency purge. It has pressure gauge for the case, pressure gauge for the differential. We also have transmitters for both of those. It also will have the supply pressure of the CO2 and H2 with transmitters. This is the complete package. We've used this on several Siemens Westinghouse systems. We have these in West Virginia, down in the Caribbean, Florida, pretty much across the country and into the world. Everything we do is rated for use in a hazardous area, with the exception of a portable gas analyzer that's connected and moved away from the direct area and piped in. And here's an outline that shows that total system, where it's we as a gas station, which we use modules in the gas station. So you have on the left is the gas manifold module. Top right is your hydrogen monitoring system with your pressure gauges, transmitters, and the bottom right is going to be your supply pressures for hydrogen and CO2. This system can also have an automatic top off. So if the pressure drops in your case, it can automatically open a solenoid valve to push the pressure up and then shut back off. Everything we do on this is stainless steel tubed and intrinsically safe. We have explosion proof housing on the bottom right hand side that keeps us from any sparks or arcs causing a bad situation. This is a typical P&ID of a fully automated system with redundant analyzers, pressure transmitters, gauges, valves, spool piece, and also what we look at is the customer interface. This is only one half of two interface boxes when we have a fully automated gas manifold, but you can see how much information that we have there that you can take out, you can bring back to your DCS, you can trend it, you can log it, and it gives you complete visibility of what's available and what's happening down there in the field. All right, well, thank you. This is my first round doing this. I'm sorry for the couple of bumps there where I got myself lost, but I think we got back on track. If at any point that you'd like to give me a call, send me an email, set up a site visit, I am available. I do enjoy what I do. I like getting out and seeing you people and being part of helping your plant become more efficient and safe. The bottom line here is we're all about safety, risk mitigation, and reliability. So let me know how I can help you out. And
Thanks, Mark. Yeah, we're gonna we
do we
had
have
some
any more questions?
Yep, we sure do. Yep, so thank you. And you know, I enjoyed hearing your dog. I hope it's okay. This is a
Yeah,
live event, so this is real life. You know, this is real life.
it's the way we have to do things these days.
That's right, exactly.
He's got pneumonia.
Oh no, okay, so we're going with the flow. So does E1 do turnkey installations of the equipment that you were just mentioning?
Yes, we have done turnkey installations. We've done a lot of them actually lately. And we will pull together the electrical, mechanical contractors. And what we do when we do this, we have site supervision on E1 person on site every day through the entire demolition and installation process to make sure we identify wiring, piping is all correct, things are installed properly, piped correctly. But we also will do site management alone, utilizing your contractors, and that way the plant has a little bit more leverage if things don't move smoothly or things get stuck. If we know that these contractors have worked with you, we can work together to make sure things get done as scheduled on time.
Okay, so good collaboration there. This is a question from Doug. Does the automated system with hydrogen monitoring also monitor seal oil pressure to keep case pressure up without blowing the hydrogen seals?
No, it doesn't monitor the seal oil pressure. What we're doing, I think this directs to a purge. So during a purge, you have a seal oil pressure that has to be maintained and a case pressure. So your seal oil system is going to maintain that pressure. What we're doing with the case pressure is modulating the vent line so that we maintain that 12 to 15 PSI or 2 to 5 PSI, whatever it may need to be. So you can modulate that to maintain it so it doesn't blow out the seals. They're independent systems, but by taking these signals into the DCS, it's actually, you have the ability to write your code in such a way that you can put that as part of the string of the code to say, if my seal oil pressure is doing this or my case pressure is doing this, we're going to modulate that vent line to make sure that we maintain proper pressures.
Okay, very good. This question from Stephen. What are the conditions that would cause an auto purge?
Conditions. Conditions, I guess anything can be written into your code if you wanted to in the DCS, but the only thing that's going to start it is going to be based on an operator decision of something going on in the field. The reasons to do an automated purge is I have one plant that had an instance where they had a fire in the seal oil system. And if you think about it, all your gas manifolds are sitting right underneath the seal oil system if they're in the basement. And a fire's going and you got guys down there, 2 or 3 guys trying to rapidly get a generator purge. They're standing in harm's way. So a fire or a natural disaster, emergency, hurricane, tornado would be a reason to start an auto purge.
Okay, and this question, again from Anonymous, very busy. How long typically does a fully automated purge take versus the normal timing without it?
That's a good one. It is very dependent on what you have on site. It's pipe size, type of CO2 storage you have, how far the pipe is and storage is from the generator. But I have seen and have been told of fully automated purges with the correct equipment and, you know, everything going perfectly, probably no faster than an hour to go from H2 to CO2. Anything under that, based on flow rates and recommendations from manufacturers and stress on pipes, probably isn't realistic. But anywhere from an hour to 3 hours.
Okay, very good. Jose is asking, does E1 have any installations in geothermal plants? And if so, what are the applications?
At this point, I don't believe we do, but I have been in contact with a plant in Northern California that we are actually looking at redoing their entire hydrogen monitoring systems, including core monitors, hydrogen dryers, gas manifolds, purity monitoring, the whole thing. And it's a process that will take a bit, but I have been out to a couple of plants, and we're working on projects to push that forward in the next years.
Good. And I think I think in the Idaho, Utah area, we might have a few, but we'll in our follow-up email on Q&A, we'll definitely identify that. Another question. Oh, Mark, did you see that question come in? Is it better to heat the CO2 regulator or to buy a CO2 heater? Cost difference is high.
It's very high. It's a big difference. Heating the heated CO2 regulator, we actually, one of the plants we ended up going to on that journey that I just started this out with, purchased a heated regulator. They're about $300, $400, something like that. It solved their regulator freezing, but I'm not sure if that was freezing of the regulator or just frost buildup on the outside of the regulator. I think it's all dependent very much on what kind of CO2 storage you have. If you have high pressure bottles, I think a trim heater or a vaporizer, even though it's going to cost you more, would be more efficient and a more realistic solution to make sure that that doesn't happen. But again, it would be coming out to look at and see what you have. I mean, the diameter of the pipe, the length of the pipe, all have impact on freezing. And the big thing that I've found is that being above 60 PSI has really reduced and helped with these freezing issues. Combine that with a heated regulator for frost buildup on the outside and vaporizer, whether it's a heated vaporizer, electrical, water heated, steam heated, or even ambient vaporizers are out there these days that can achieve fast purges in the range of, in that 1 hour range, once we look at the rest of the things that go with the system.
Okay, and Jason wants to know above 60 PSI discharge or 60 PSI drop?
No, 60 PSI pressure to the generator. So that would be, instead of feeding at the 15 or 30 PSI that I've seen at many places, pushing that up to 60 PSI or above as your feed pressure. The pressure that's maintained in the generator is going to be controlled by your vent valve, and that can be as low as 5 PSI to 12 PSI, whatever you need to hold those seal oil systems.
Okay, very good. What about hazardous area classification?
Yes, all of these units that we put in are rated for hazardous area, rated for use with hydrogen.
Okay, very good. And that looks like all the questions that have come in. So I think it's a wrap at this point. I'd like to thank you all for attending and joining today's session. And we look forward to seeing you soon. Be well.
Thank you.